Something appeared on the Sun at the very end of February, quietly, without any particular announcement, without any weeks of build-up or widespread coverage, and within a matter of days, it had risen to become one of the most active regions on the entire Earth-facing solar disk. Not after months of gradual development, not after a series of early warning signals that gave observers time to prepare a proper watch, within just a few days. And what it is doing right now is not simply how fast it climbed to that position, it is the direction it is currently travelling, and what that direction means for the days directly ahead of us. Stay with me for the next few minutes, because in this video we are going to cover exactly what AR4381 is doing at this very moment, why forecasters are paying it specific focused attention during the first week of March, what the confirmed flare activity from this region tells us about how it is currently behaving, what the rotation timeline looks like, and why the centre of the Sun's Earth-facing disk is the position that matters most right now, and what scientists are specifically watching for as this window continues to unfold. Every piece of this story is confirmed. None of it is projected. Here is what made this region different from the very moment it appeared. Most sunspot regions that eventually become significant give forecasters at least some advance notice. There is usually a recognizable pattern, a quiet magnetic development forming on the far edge of the Sun's visible face, a gradual increase in complexity, a few early low-level flares that give scientists time to catalogue the region before it becomes truly relevant to Earth-facing forecasting. AR4381 did not follow that pattern. It arrived, and almost immediately it started producing. And by the time most people even had the name in their vocabulary, this region was already sitting at the top of the flare activity chart, not alone, but tied for the lead with a second newcomer that had rotated into view during the same narrow window. That detail is worth pausing on. Two new active regions, both climbing the activity chart simultaneously, both producing flares, both in the process of rotating toward the Earth-facing zone at nearly the same time. That combination is not a regular occurrence, and it is exactly the kind of development that shifts forecaster attention from routine monitoring into something more deliberate. That is exactly the situation this week, and it is still developing. Before we go any deeper into what AR4381 has done and where it is heading, if this kind of real-time space weather coverage is the reason you come to this channel, hit the like button right now. It takes 1 second, and it genuinely helps this content reach others who are following the same story as closely as you are. Subscribe if you have not already, because what we are tracking this week is still actively unfolding, and you will want to be here as each new development comes in. And drop a comment right now. Tell me where you are watching from, and whether you have caught any aurora activity in your area over the past few days. I read every single comment, and right now I especially want to know how far south those lights are reaching. The flares this region has already produced are not projections, they're confirmed, catalogued events that tell a specific story about how this particular region has been behaving since the moment it appeared, and that story matters not just because of what has already happened, but because of where this region is physically located on the Sun right now and the direction it is moving. AR4381 is no longer sitting at the edge of the Sun's visible face. It is rotating toward the central part of the Earth-facing disk. The centre of that disk is where any flare would be pointed most directly toward Earth, making it the most relevant position for space weather effects. That rotation is underway right now. The first week of March is the window when that alignment becomes most meaningful. Scientists are now tracking whether AR4381's confirmed flare activity has peaked or is still building. To understand what that assessment looks like, we need to go back to the very beginning of this region's story, because how AR4381 first emerged and what it produced in those first few critical days tells us a great deal about how to read where this is heading. The flare record this region built in those first few days is where this story gets specific. The story of AR4381 starts not with a dramatic eruption or a major geomagnetic event. It starts with something much quieter. A new sunspot group rotating into view on the northeastern edge of the Sun's Earth-facing disk in the final days of February. At first glance, it looked like what many new regions look like in their earlier stages, a developing magnetic structure with potential, but no confirmed significant activity yet attached to its name. Nothing that would immediately draw headlines. Nothing that would cause a forecasting centre to shift its primary focus. But within just a short span of time, the character of AR4381 started to reveal itself. It began producing C-class flares, the confirmed activity that forms the baseline record for any active region, and the specific sequence of what it produced is exactly the kind of data that tells scientists whether a region is stable, whether it is building, or whether it is showing a particular kind of progression that warrants closer attention. The confirmed flare sequence from AR4381 reads like a progressive track, a C4.7, a C5.3, a C5.9, each one catalogued, each one a step higher along the scale than the one before it. That progression matters because it is not random variation. It is a pattern that forecasters recognize as a region finding its stride. A region producing in ascending order has not peaked and settled. It is still climbing. And that is the specific behavioral signature that forecasters were noting as March arrived. By the time EarthSky confirmed AR4381's position on March 1st, this region was not just a developing newcomer anymore. It had established itself as one of the lead flare producers on the entire Earth-facing solar disk, and it had done so while tied with a second active region that had also rotated into view during almost exactly the same window. That unnamed newcomer matched AR4381 in the flare production count. 2 regions, both new, both at the top of the chart, simultaneously. That pairing is one of the more notable aspects of this story. When one new region rises quickly, the story is about that region. When 2 new regions rise at the same time, the story becomes about what is happening across the solar disk as a whole, what is driving that level of activity simultaneously from 2 separate sources. Forecasters are watching both regions closely as this week continues. There is something else that arrived in that same time frame, and it is directly connected to the activity picture that AR4381 emerged into. On March 1st, a coronal mass ejection reached Earth. Not from AR4381 specifically. This particular CME originated from earlier solar activity, but its arrival at Earth on the same day that AR4381 was confirmed as a lead flare producer creates a picture of the Sun that is more active in aggregate than it might appear from any single headline. The Sun did not just produce one notable thing this week, it produced several. And AR4381 is the piece of that picture that is still actively developing as we speak. Now, here is what that confirmed flare sequence actually tells us in practical terms. C-class flares are real solar events, confirmed magnetic releases from an active region that sit in the lower range of flare intensity. They are not the events that make headlines, but a region producing them in a rising sequence, as AR4381 has done, is one that forecasters take seriously. AR4381's confirmed flares are C-class. That is the established, verified record of what this region has done. The question that forecasters are now working through, and the question that makes this region's current position on the Sun so relevant, is what a region showing this kind of ascending C-class progression might do as it moves into optimal Earth-facing position. That is not a question with a predetermined answer, it is an active watch. What gave that watch additional weight is the timing of this region's rise. AR4381 did not climb to the top of the activity chart during a period of otherwise quiet solar conditions. It climbed during a week when the Sun was already active in multiple ways, a CME in transit, multiple active regions developing simultaneously, and elevated conditions already being monitored. For AR4381 to rise to the top of the flare production chart within that environment, and to do so in a matter of days from first appearance, is the kind of development that moves a region from routine monitoring to something that forecasters note as being worth a sustained, careful watch. SpaceWeatherLive confirmed the multiple active region picture as this week opened. NOAA issued the probability forecasts. EarthSky placed AR4381 at the center of the story. These are not single-source observations. This is a consistent picture emerging from multiple tracking sources at the same time. And the reason all of that matters is not just what AR4381 has already done, it is where AR4381 is right now. Because as of this moment, this region is still rotating, still moving, and the position it is heading toward is one that forecasters are watching with very specific eyes. What that position looks like, and why the center of the Earth-facing disk carries the weight it does in this story right now, as this video plays, on AR4381 is sitting on the northeastern portion of the Sun's visible face. Not at the very edge anymore, but not the center either. It is somewhere in between, and that in-between position is, in a specific way, the most important part of this story. Because the Sun rotates, slowly, steadily, continuously. And regions that appear on the Sun's northeastern face rotate across the Earth-facing disk and eventually reach the center, the position directly in line with Earth, before continuing toward the western edge and eventually rotating out of view entirely. AR4381 is currently in the first part of that journey across the Earth-facing disk, and the timing of that journey places the region's arrival at optimal Earth-facing alignment right in the window of the first week of March. And understanding why that position matters requires no complex astronomy. Think of the Sun's visible face in 3 zones: eastern edge, centre and western edge. Regions on the eastern edge are still rotating into position. The centre zone is where any flare is aimed most directly at Earth. AR4381 is currently moving from the eastern zone towards centre. As they rotate toward the centre zone, their orientation toward Earth becomes most direct. Any eruption from a region at centre alignment travels along the most direct possible path toward Earth's position in space, not at an angle that causes a CME to pass above or below or to the side, directly along the line of sight. AR4381 is rotating toward the centre of the disk right now. The first week of March is the window during which this alignment becomes increasingly direct. Forecasters at NOAA are watching this rotation as part of the overall probability assessment for the week, and that assessment currently places a 25% chance of M-class flares and a 5% chance of X-class flares from the active regions currently on the Earth-facing solar disk. Those numbers deserve a moment of honest context. A 25% probability of M-class activity means that forecasters, looking at the current conditions across all the active regions on the visible solar disk, put the chance of at least one M-class flare occurring at roughly 1 in 4. That is not a guarantee, it is not a near certainty, but it is also not background noise. For comparison, on a quiet solar week with little active region activity, that number would be much lower. The fact that it sits at 25% this week is a reflection of the collective state of the Earth-facing disk, and AR4381, given its confirmed flare progression and its movement towards centre alignment, is a meaningful contributor to that number. The 5% chance of X-class activity tells a different story. That number is honestly low. Forecasters are not treating this as a week with high probability of an extreme event. What they are treating it as is a week where the conditions on the Earth-facing disk are elevated enough to warrant sustained monitoring, and where AR4381 specifically is the region that carries the most active profile among those currently visible. It is worth being very clear about what this means and what it does not mean. This is a watch situation. Scientists are monitoring an active region that has shown a specific behavioral pattern, is carrying a magnetic configuration that supports continued flare activity, and is rotating into the position of maximum Earth-facing alignment during a well-documented window. That is the confirmed picture. It is not an emergency forecast. It is not a warning of imminent disruption. It is a professionally active monitoring situation, the kind that space weather forecasters conduct regularly, but that warrants public awareness when the specific combination of factors is this well aligned. There are currently 3 active regions on the Earth-facing solar disk that are being tracked. AR4381 is one of them. The unnamed newcomer that arrived in the same window and matched AR4381 in flare production is another, together with a third active region already present on the disk. They form the current configuration that is driving both the elevated flare probabilities and the sustained monitoring attention this week. But when at least 2 of those regions arrived recently, both showing rapid development, and one of them is carrying a confirmed ascending flare sequence while rotating towards centre, the combination of those specific conditions happening together in the same week is the reason this story is being told right now. For viewers who have been following space weather through the later stages of solar cycle 25, this may feel familiar in one sense. The Sun has been more consistently active over the past year than during the quieter years earlier in this cycle. There have been other weeks with notable active regions, other M-class and even X-class events, other periods when forecasters were tracking multiple regions simultaneously. AR4381 fits within that broader pattern of heightened cycle activity, but it stands out within this specific week because of the speed of its emergence, the specific pattern of its confirmed flare production, and the timing of its rotation towards centre alignment. What forecasters are actually watching, the specific technical picture they are building as this week continues, goes deeper than just the rotation angle. It involves the internal structure of this region's magnetic field, and the specific way that structure has been producing flares, and the gap between what has already happened and what that pattern suggests about what could happen in the days ahead. That monitoring picture, what scientists are measuring and why it matters this week, is what comes next. To properly read what AR4381 means this week, you cannot look at it in isolation. You have to look at the full picture of what the Sun has been doing, not just in recent days, but in the days immediately before this region appeared, because the context surrounding AR4381's emergence is part of what makes its rise so striking when you see it laid out. Go back to the final days of February, just before AR4381 started drawing attention. The Sun had just passed through a period of spotless days, a brief window when the Earth-facing disk was quiet, carrying no significant active regions, producing no notable flares, and then, almost immediately after that quiet stretch ended, AR4381 appeared, a new region, arriving directly out of a window of unusual calm and rising to lead flare producer status within days. The contrast between those spotless days and the sudden arrival and rapid rise of AR4381 is not coincidence. It reflects the rhythm of the current solar cycle, but it is the kind of contrast that makes the story of this region land differently than it would if the Sun had simply been continuously active throughout. The quiet came first, then AR4381 arrived, and it arrived fast. That arrival did not happen into a vacuum. By the time AR4381 was confirmed as one of the lead flare producers on the Earth-facing disk on March 1st, the Sun was already presenting a multi-region active picture. 3 active regions on the Earth-facing disk, a CME that had completed its journey from the Sun and arrived at Earth on March 1st, not from AR4381, but from earlier solar activity that had been in transit. And elevated electron radiation levels confirmed through March 3rd, a reflection of the overall elevated state of conditions in near-Earth space. All of that was already in place when AR4381 reached the top of the activity chart, which means that AR4381's rise did not initiate an otherwise quiet week. It arrived into a week that was already carrying elevated conditions across multiple indicators, and it became the most actively developing piece of that picture. SpaceWeatherLive confirmed the multi-region picture as the week opened. NOAA's electron radiation data showed elevated levels persisting through the early days of March. The CME arrival on March 1st was recorded and confirmed by monitoring networks. These are separate data points from separate sources, all pointing at the same general picture, a Sun that is producing more than a single isolated event this week, with AR4381 sitting at the center of the active picture as the region that arrived most recently and is developing most actively. Now, why does this broader context matter? Because when you look at AR4381 alone, its flare sequence, its rotation, its magnetic classification, you get one level of information. But when you place it within the full picture of what the Earth-facing disk looks like this week, you get a different, more complete level of information. You're not looking at one unusual region in an otherwise quiet environment. You're looking at one particularly active newcomer within a week that is already running at an elevated level by multiple measures. That distinction is important for reading the probability numbers honestly. The 25% M-class probability that NOAA issued this week is a disk-wide number. It reflects the combined probability from all active regions currently visible, not just AR4381. The fact that AR4381 is one of the lead flare producers in that group means it is contributing meaningfully to that number. But the number is not solely about AR4381, and understanding that is part of reading space weather accurately, rather than attributing more to a single region than the data actually supports. What this week's picture does confirm is that the Sun is not in a quiet phase right now. It is in a phase of multiple simultaneous active regions, a recently arrived CME, elevated radiation levels, and a newly emerged region that has shown a rapid and specific development pattern. That combination, all happening in the same short window, is the actual story of this week. And AR4381 is the freshest, most actively developing piece of that story. There is one more layer to this picture that makes the context even more significant. The spotless days that preceded AR4381's appearance were not the only notable feature of the Sun's recent behavior. The transition from quiet to active happened with a speed and sharpness that forecasters noted. When the Sun moves from spotless to multi-region active in a short time frame, it is the kind of shift that draws attention, not because it is unprecedented, but because a fast shift from quiet to active is something forecasters always note as worth tracking. Whether this active period holds or settles back is something forecasters are working through right now. And the specific thing they are watching most closely, the technical indicator that will do the most to answer that question in the days ahead, is not simply AR4381's rotation, it is the internal structure of AR4381's magnetic field and what that structure suggests about the region's capacity for continued and potentially higher level flare production. That magnetic picture and what it tells forecasters about AR4381's next moves is what we cover now. For AR4381 specifically, the most important thing forecasters are watching right now is its magnetic structure, because that structure directly determines what the region is capable of producing next, and in the case of AR4381, the magnetic classification it currently carries is the starting point for understanding everything else about why this region is being monitored the way it is right now. AR4381 currently carries a beta magnetic classification, a bipolar structure with both positive and negative polarity sitting adjacent to each other, and that structure directly shapes what this region is capable of producing. A beta classification describes a sunspot region that contains both positive and negative magnetic polarity within its structure, with those opposing polarities separated from each other in a way that does not yet create the conditions for the highest intensity flare production. It is a magnetic setup that can and does produce flares. AR4381's confirmed C-class sequence is direct evidence of that, but that in its current form sits below the classifications associated with major X-class events. Beta is not an alarm level. It is not a classification that, by itself, tells you a major event is imminent or even likely. What it does tell you, when combined with the flare production behavior AR4381 has already shown, is that this region has the magnetic foundation for continued activity. The confirmed C4.7, C5.3, and C5.9 flares were not produced by accident. They were produced by a region with a specific magnetic structure that was actively releasing energy. The question forecasters are now tracking is whether that magnetic structure remains stable at beta, whether it becomes more complex, moving toward a configuration associated with higher intensity activity, or whether it begins to decay and quiet down as it continues across the disk. Magnetic classifications can change. A region that enters the Earth-facing disk at beta can develop into a more complex configuration during its transit. It can also hold steady, and it can begin to simplify as the magnetic energy that drives its activity gradually releases through smaller events. Forecasters at NOAA are watching AR4381's magnetic evolution specifically because that evolution will do more than anything else to determine whether the 25% M-class probability that covers the current disk this week remains relevant, increases, or decreases in the days ahead. The flare output trend is the second thing scientists are tracking closely. The confirmed sequence, C4.7, C5.3, C5.9, is a progression. Each flare in that sequence was slightly more energetic than the one before it. That is not a dramatic escalation. These are all C-class events. But a region producing in a consistently ascending pattern is showing something specific about how it is managing its magnetic energy. It is releasing in incremental steps rather than holding, and those incremental releases are so far slightly increasing in magnitude. What forecasters are asking now is whether that ascending pattern continues, plateaus, or shifts. If the next confirmed flare from AR4381 is at M-class level, that represents a meaningful step change in the region's output and would immediately draw greater focused attention. If the region produces another C-class event similar in magnitude to the C5.9 it has already fired, that suggests the ascending pattern may be stabilizing, and if activity from AR4381 quiets below its established C-class baseline, that would suggest the region's most active phase may have already passed. None of those outcomes can be predicted with certainty right now. That is the honest answer. What can be tracked is the pattern, and right now the pattern is one of a region that arrived recently, rose quickly, and has been producing in an ascending sequence while rotating towards center alignment. That combination of factors is what places this region at the specific kind of watch level it currently holds. The third and perhaps most practically significant thing forecasters are monitoring is the timing of AR4381's arrival at center alignment on the Earth-facing disk. As described earlier, center alignment is the position where a flare or CME from a region would travel most directly toward Earth. AR4381 is moving toward that position during the first week of March. The specific window of closest alignment, when the region is most directly facing Earth, is the part of this week that carries the highest relevance from a space weather impact perspective. When a C-class flare fires from a region that is well off to one side of the Earth-facing disk, its effects on near-Earth space are limited. When an M-class flare fires from a region near center alignment, the geometry of that position means a much larger fraction of whatever that eruption produces is aimed in Earth's direction. That is not a statement about what AR4381 will do. It is a statement about why the center alignment window matters as a specific variable in how forecasters are reading this week. The difference between a MAC-class event from a region at the edge of the disk and a MAC-class event from a region near center alignment is not a trivial one. It is a geometric reality that forecasters factor into every probability assessment, and right now AR4381 is moving through the portion of the disk where that geometry is becoming increasingly direct. Here is the part of this story that connects to something many of you have been watching for weeks, and not just to AR4381 in isolation. This region did not appear at a random point in the Sun's activity cycle. It appeared at a very specific moment in the overall trajectory of solar cycle 25. And understanding that moment, what the broader cycle is doing right now and why it matters for reading AR4381 correctly, is the piece of context that pulls this entire week's picture into full focus. That cycle context is what gives this week its full weight. Here is the part of this story that changes how you read AR4381, not just as a single active region, but as something that is happening right now because of exactly where we are in the Sun's longer activity cycle. NOAA has confirmed that the peak window of solar cycle 25 extends through early 2026. That is the current confirmed picture from the agency that tracks solar cycle progression as part of its long-term space weather mandate. The peak, not a shoulder period, not a slow descent from a peak that already passed. The window in which the Sun is operating at its highest sustained level of activity in this cycle extends, by NOAA's confirmed assessment, into this month. That context is what transforms AR4381 from a notable active region into something that makes sense as a product of exactly this moment in time. AR4381 did not emerge randomly. It emerged because the Sun is currently in the phase of its 11-year cycle, when new sunspot regions appear most frequently, develop most quickly, and are most likely to carry the kind of magnetic complexity that drives significant flare production. AR4381 is not an anomaly within the current solar environment. It is a natural expression of the environment the Sun is currently in. For viewers who have been following solar cycle 25 closely over the past couple of years, this confirmation matters. There was a period earlier in this cycle, and in cycles that preceded it, when the common expectation was that the peak would be relatively modest, that cycle 25 would not match the intensity levels of its more active predecessors. NOAA's own revised assessments over the past year have updated that picture significantly. Cycle 25 has run more active than the initial forecast suggested, and the confirmation that its peak window extends into March 2026 means that the conditions which produced AR4381 and the unnamed newcomer that arrived alongside it, and the three-region active disk picture we are currently looking at, are not fading remnants of a cycle that already peaked. They are part of a still active peak phase. That distinction is meaningful for how you read the probability numbers this week. The 25% MAC-class probability is not unusually high for a period of solar cycle peak. During the most active portions of a strong solar cycle, extended windows of elevated flare probability are expected. What it means for AR4381 specifically is that this region arrived under conditions that are currently as favourable for active development as they will be at any point in this cycle. The environment the Sun is operating in right now is one that supports and sustains the kind of magnetic region development that AR4381 is showing. It also means that AR4381 is unlikely to be the last significant region of this cycle's peak. The extended peak window through March 2026 means that the solar conditions driving AR4381's emergence are expected to remain active through the rest of this month. The solar disk that is currently carrying 3 active regions, with AR4381 at the most active end of that picture, is a disk that reflects the Sun at the top of its current cycle's energy output, and that is exactly where NOAA's data places us right now. There is an important nuance here that is worth stating clearly. The end of a solar cycle peak does not happen with a defined boundary or a specific date that can be precisely forecast in advance. And NOAA's confirmation that the peak window extends through March 2026 is a probabilistic range, the best current assessment of where the cycle's most active period reaches. It does not mean the Sun becomes quiet the moment March 2026 ends. Cycle peaks fade gradually, But what it does mean is that this month, right now, sits within the confirmed outer edge of the period when solar activity is expected to be at or near its cycle maximum. That is the temporal context that makes this week significant. Not just because AR4381 appeared and rose quickly, not just because 3 active regions are simultaneously on the Earth-facing disk, not just because a CME already arrived and electron radiation is elevated, and AR4381 is rotating towards center alignment. All of those things are happening in the same week that sits within the confirmed peak window of one of the more active solar cycles in recent years. SpaceWeatherLive has been documenting the current solar disk activity continuously through this period. NOAA's Space Weather Prediction Center has confirmed both the peak window timeline and the current probability forecasts. EarthSky placed AR4381 at the top of the March 1 activity picture. This is a story being told consistently and in alignment across multiple established credible sources, not a single outlet's interpretation. And what that credibility-layered picture tells us, when you step back and look at it from the perspective of the full cycle context, is this. AR4381 is not just an interesting sunspot that happened to rise quickly this week. It is exactly what the sun is expected to produce during a confirmed peak window, and that is precisely what NOAA's extended peak forecast through March 2026 reflects. And the way this region behaves in the days ahead, whether it produces at the C-class level it has confirmed, whether its magnetic structure evolves toward greater complexity, and whether its center alignment window produces any activity aimed in Earth's direction, will be one of the clearest real-time examples of what Solar Cycle 25's peak looks like in practice. So what does the specific forward-looking picture actually show? What happens in the days directly ahead as AR4381 reaches its most relevant position? And what should you be watching for as this week closes and the next one opens? Here is what the confirmed data says about the days directly ahead. Let us talk about what actually happens next. Not in general terms, but in the specific confirmed picture that the current data gives us for the days directly ahead. Because this is the part of the story that answers the question every viewer following AR4381 is really asking. What should I be watching for, and when does the most relevant window close? AR4381 is currently rotating across the Sun's Earth-facing disk towards center alignment. That rotation is continuous and predictable. The Sun's rotation rate does not change based on what is happening on its surface. The region will continue moving across the disk during the first week of March. As it does, its position relative to Earth becomes progressively more direct. The window of closest alignment, the point where any activity from this region would be aimed most directly toward our position, falls within the coming days. After that center alignment window passes, AR4381 will continue rotating, this time toward the western edge of the Earth-facing disk. As it moves toward the western limb, the geometry shifts again. Eruptions from a region on the western part of the disk are aimed less directly at Earth and begin pointing away from us. The window of maximum relevance is therefore not an extended period. It is a specific window tied to the region's position during its transit across the central part of the Earth-facing disk. That is the specific window forecasters are tracking right now, and it is the window that makes the days immediately ahead the most meaningful portion of this story. Here is what the confirmed picture currently says about what to watch during that window. The flare probability issued by NOAA, 25% for M-class events, 5% for X-class, represents the collective assessment for the Earth-facing disk as a whole. AR4381, given its confirmed flare production and its movement towards center alignment, is among the regions contributing most directly to the M-class probability as this week progresses. If AR4381 produces an M-class flare during the period when it is near center alignment, that event would carry a meaningfully different potential impact profile than the C-class flares it has already confirmed. C-class flares from AR4381 while it was on the northeastern portion of the disk produced catalogued events with limited Earth-directed effects. An M-class flare from center alignment would be the next level up from what AR4381 has confirmed so far, not automatically a major event, but one that forecasters would watch closely for any associated coronal mass ejection and for that CME's potential trajectory. A flare and a CME often accompany each other, but their effects on near-Earth space are different. What forecasters are monitoring is not just whether AR4381 produces an M-class or higher flare, it is whether any such event is accompanied by a CME, and whether that CME would be directed toward Earth given the region's position at the time of the event. If AR4381 produces a stronger flare near center alignment with an associated CME aimed at Earth, forecasters would update the watch status and assess any impact on near-Earth conditions. That scenario is currently assessed at a chance level, not a probability level, that suggests it is the most likely outcome of the week. But it is a scenario grounded in the confirmed data rather than speculation. And it is what the monitoring picture for AR4381 is specifically designed to detect as quickly as possible. What should you be watching for in the next several days? Watch for any confirmed M-class or higher flare event attributed to AR4381. Watch for NOAA probability updates, which are issued regularly and will reflect any changes in the region's magnetic structure or flare output. Watch for confirmation of whether any significant flare from this region is associated with a CME, and if so, what trajectory that CME is on. SpaceWeatherLive and NOAA's Space Weather Prediction Center both provide near real-time updates that are accessible, clearly written, and reliable. And if you are at a latitude where auroras are occasionally visible, particularly viewers in the northern parts of the northern hemisphere or the southern parts of the southern hemisphere, this is a week to keep an eye on the aurora forecasts. Elevated conditions in near-Earth space do not always produce dramatic aurora displays, but the current combination of multiple active regions, a recently arrived CME, and elevated radiation levels creates a background environment where aurora activity can appear with less provocation than usual. That is not a promise of lights. It is a reflection of the elevated baseline conditions this week is running on. There is one more thing worth saying before we wrap up this part, and it reflects something more important than any single probability number or flare event. The picture that AR4381 represents this week, a rapidly emerging active region, rising to lead flare producer status in days, carrying a beta magnetic classification, producing in an ascending sequence, and rotating towards center alignment during a confirmed solar cycle peak window, is one of the more complete, multi-factor active monitoring situations the Earth-facing solar disk has presented in this recent stretch of the cycle. That is why it is worth following closely right now, and whether this week ends with a significant event, or with a quiet passage through center alignment and a fade toward the western limb, the story of how AR4381 developed tells us something real and specific about where the sun is right now. What all of that confirmed information adds up to, what the key takeaways from this week's picture are, and where to focus your attention in the days ahead. Here is the confirmed summary of everything this week's data tells us. Here is the confirmed picture of where things stand. AR4381 appeared on the sun at the very end of February. Within days, it had risen to become one of the most active regions on the Earth-facing solar disk, tied with an unnamed newcomer that arrived in the same window. Its confirmed flare sequence, C4.7, C5.3, highest C5.9, documents an active region producing in ascending order, suggesting a region that was building rather than settling when these flares were recorded. It currently carries a beta magnetic classification. It is rotating towards center alignment on the Earth-facing disk during the first week of March. NOAA's current probability assessment places McClass flare activity at a 1 in 4 chance across the active disk. The 5% X-class probability reflects a lower but non-negligible possibility. All of this is happening within a confirmed solar cycle peak window that NOAA has extended through March 2026, meaning the conditions that produced AR4381 are not fading conditions but peak conditions. NOAA's data confirms the sun is still in its most active phase, and AR4381 is a direct product of that. What this week is not, it is not a crisis. The data does not support that framing, and honest space weather coverage does not use it. What this week is, a well-documented, and multi-factor active monitoring situation involving a rapidly developed active region approaching center alignment during a confirmed cycle peak window. And that is genuinely one of the more complete and interesting stories the sun has offered in recent months. For viewers who have been following Solar Cycle 25 through this channel, AR4381 is a natural continuation of the story you have been watching. For viewers who are checking in specifically because of this region, the broader picture is worth understanding because AR4381 does not stand alone. It sits within a week of elevated solar activity, a cycle at its peak, and a set of monitoring conditions that will continue to develop in real time. The sources that are tracking this story accurately and continuously include NOAA's Space Weather Prediction Center, SpaceWeatherLive, and EarthSky, each providing confirmed data updates as the week progresses. Those are the places to check as AR4381 moves through its center alignment window and forecasters update the probability picture accordingly. Before you go, I want to ask you something directly, and I genuinely want to know the answer. If you are in a region where auroras are visible, even occasionally, have you seen any activity over the past few days? Are the lights showing up at lower latitudes than usual? Are you somewhere in Scandinavia, Canada, Scotland, or the northern United States and noticing anything? Drop it in the comments right now. That information from viewers on the ground is genuinely useful, and it builds a picture of what the current elevated conditions in near-Earth space are actually producing at the surface level where you live. If this kind of coverage, specific, confirmed, real-time, and honest, is what you follow this channel for, subscribe if you have not already. Hit the like button before you leave. It helps more people who are following AR4381's story find their way here in the days ahead, when this region reaches its most relevant window. This is a story that is still unfolding. AR4381 has not finished its transit. The first week of March has not closed. The probability window is still open. And whatever happens in the days ahead, whether this week ends with a significant solar event or with a quiet passage through center alignment, this channel will have the confirmed picture for you as it develops. Stay with this channel as the story develops, and drop your aurora report in the comments below.